Assalamu alaikum warahmatullahi wabarakatuh. I am Kehir Saki, and today we're going to look at how to reverse a linked list, right? And first of all, you should know, what a linked list is, obviously. Then you should know how to traverse a linked list, and that will suffice, for this video, right? So there are so many ways by which we can reverse a linked list. And if you spend some time with it, you can come up with your own, right? This is not so complicated. So I'm going to share my screen and this band here, and I have drawn a simple list, right? So what we have here is we have this head, which is storing the starting node of the uh, which is storing the address of starting node in our list, right? Then that starting node is pointing or having the address or storing the address of next node, right? Then that next node likewise is storing the address of that its next node, right? And the end of the list is having null in its next pointer, right? In its pointer. So that means we are at the end of the list, right? So you should know how can we traverse this linked list programmatically, right? And one of the ways by which we can reverse this linked list is by using simple array like algorithm, you know the algorithm by which we reverse an array. You should know this algorithm, and I assume that you know. So so what we are going to do, we are going to attach logical index to each node in our list. So this is going to be at index 0, this 1, this 2. You might wonder, hey Kaiser, there's no index in linked list, right? That's true, but we are logically, you don't have to store these indexes. We are logically saying that because we have we have a property in our linked list, and that is length, right? Length should have count of how many nodes we have in our list, right? At this moment in time we have 4 nodes, so length should have 4 value, right? And so by this we will we can assign, or so how can this is at location 0. You will use a for loop, and you will start from I, you know and you will point to first first node in the list, right? Then you will increment I and also point to the next, and increment I, point to the next, and increment I, point to the next, until this I is less than length. And this is the condition. And also you can use this while current is not null, or current of next is not null, whatever you are happy with. So by this you will create two methods, which is get and set. Get should be like this: list, get, right? It should demand an argument, and there's index, right? So which means that it's like this: hey, get me an element at index this, right? Or location or position, whatever you like to call it. So if I say get me an element at index, let's say 3. So this is 3. So it should this method should return me D, right? Likewise, we should have another method that's set, right? So it should take 2 arguments, index and value, right? So if I say set 3k, so 3 is this index, and it should put k there, right? But as you can see, this is very time consuming, right? These are not cheap operations, right? Because we are each time we have to get the element, we are traversing whole list. Like if we have 10,000 elements in our linked list, then if we say get me element at you know 10,000 position, right? At 10,000, then it has to traverse all nodes and get return you the value. And likewise, if you say get me an element at 999, then it will also traverse the whole list and give the element. So as you can see, this is very time consuming, so this is not good. But still you can implement array logic with this these two methods, right? Very simple. And another solution to this problem is using a stack, right? So I assume that you know what's a stack and what are the basic operations of a stack, and push and pop, right? So we have a stack, and so what we are going to do, we are going to traverse the whole list and read it, uh, and value of each node one by one and push into the stack. So suppose if we are at this node, we are going to read its value and push into the stack, and increment the pointer and point at B and read its value, push into the stack. C, then C, read its value, push into the stack, and then D. So after traversing the whole list, we have to start again, right? So we will start at this node. What we will do at this position, at this moment, is we will pop, right? We will pop the element, which is D. So pop method will return you element D. So what you are going to do, you are going to overwrite element D at this position. So you are at this position right now. So you are going to read the value, pop the value, and that is going to return you D. So you are going to write D here, right? Likewise, you are going to read value, increment, advance the pointer, right? Then pop the value, which is C. Sorry, I mean, you should know, this is simple, you should know this, pop the value C, right? Then go right here, pop B, right? Right here, and likewise A. So we have in stack A, so we should pop it, pop will return, so you will override A and you will write it here. Simple enough, right? So at the end of the day, we will have our list as reverse, right? Also, you can use array, and I assume you can do that yourself, right? This is not so complicated, but very interesting, and most what I should say, efficient solution would be to use uh, as we have this linked list, we have links, right? So we can alter these links, and we will reach at the reverse of a linked list. So how can we do this, right? So we will start at this, right? We will make a pointer P, right, which will point this, right. So first of all, I should give you an idea how it's going to work, right? So what it's going to do is this first node, it should have its in its next, it should have its next null, right? That means this that will signify that this is the last node in a list at the end of the day. So and when C, and when you will be at C, you will going to make its next point to D. Likewise, you are going to make B's next point to C. Likewise, you are going to make A's next point to B, and make head point to A, right? So when you are going to read, you are going to read it backwards, right? So you're going to have base address of this node in your head pointer, and that node is going to have in its next base address of this node, and likewise this node, and this is going to have null, right? Simple enough. I hope you understand this. So how we are going to do this, right? So we will take a pointer, right? We will take a pointer P, right? We will make it point to starting node. No, so we have to take another pointer, because we have to make this point to this, right? Or you can excuse me. So you can imagine it like this. You are going to take pointer here, right? So you are going to take a pointer here. So you have to say C of next, which is this, right? And make it point to this previous node, right? So this previous node, there should be a pointer pointed this node, right? Let's say we have a pointer P. So you have to make C point to C of next point to P, right? So this will have address of base address of this node. But you see there's a problem. When we say C of next, we are overriding this address. Whatever this address value was here, that was you know address of this remaining list, we are overriding this. What that means is that when we say C of next is called P, we are just losing the address of whole remaining list, right? So this is not good. So what we have to do is we have to take another pointer n, right? So this is these are short forms for previous, current, and next, right? So this is going to n is going to hold that current address, not current address, sorry, the address of the remaining list, right? So after this operation, c is called c of next is called P, then we are going to advance all these pointers. So n is going to point here, right? C is going to point here, right? P is going to point here, right? N is going to point here. Then we will say again C of next, which is this, make it point P, which is this. Then after this operation, we will advance the pointer again, all the pointers. So this n will advance and it will point to null, right? Which is this, right? And this C will point to this, and this P will point to this. Let me clear this out. Okay. Then at this moment, we will say make C, right? Make C of next point to P. So this will have this address, right? And as n become null, we should stop, right? N became null, we should stop. Then we will say after these iterations, we will say at the end, we will say head is equal to current. Current is pointing this, so this will become our new starting node in our list. So we say head is equal to current. That means that next time when we are going to read the list, we are going to start from A, right? This is simple enough. So I will show this to you with only two nodes. That way you will get it better, right? And I will also write pseudocode. This is very simple. If you sketch it out on a sheet paper, you will get it, right? This is not so complicated. So what we are going to have is let me take, okay, so we are going to have void reverse, right? So we have 3 pointers, right? We have 3 pointers, which is previous, right, is equal to null, and current, which is null, and next, right, which is going to point to head at first, right? And we should loop while next is not null. Whenever next becomes null, that means we have altered all the nodes in our list, and the list is reversed. So we have to stop at this moment when next will become null. So while next is not null, right? Okay, so what we will say we have to advance each time we iterate. We have to advance these pointers. So previous will become current, right? Wherever current was pointing, previous will point to that, and current will advance also. It will point what next, and next has also to advance. So it will say next of next of next. Assuming that next position is the pointer, this position, or I should describe a structure first, right, for this, so we'll get better idea. So struct node, and we have in data, and we have pointer next position, like this, right? So when we have advanced all the pointers, we will say what we will say. We will say current is called previous. Sorry, current of next, right, is called previous. And after all, we have to say that is called current, right? And we will close the function. So let's emulate this on two nodes, only two nodes. So we had this. Let's assume here is null. So at first, previous is null, current is null, and next is null. So we have previous, current, next, right? Previous, current, and next. So we are setting P and C at first null to null, and we are saying, and this in insert point head, right? Then what we are saying is, we're saying while next is not null, next is pointing to something, so it's having value, so it's not null, so it's going to continue. Previous equal current. So we are saying previous, wherever current was pointing, make it point at that. Current is pointing at this moment, current is pointing null, so we are still making previous point to null. And then we are saying current is called next, right? So which means next is pointing at this node in this moment, right? We are saying wherever next is pointing, make C point at that node, right? So C will point at this, right? Then we are saying next is called next of next position. So wherever this, whatever this error, this next position is having a value, we are saying make it equal to what, next. So logically this next n, this n will point to next node, right? So it will point at this. Then what we are saying current of next, which is this, make it point to previous. So previous at this moment is having null, so we are saying put null. So this expression will evaluate to null. We are saying current of next, which is this, we are saying make it equal to null, so null, right? This having null, right? So logically this connection is no more there, right? Then what we are saying, this loop ends here, right? It will start again while next is not equal to null. Is next null at this moment? No, next is pointing to C, so this is null, not null, so this will continue. We are saying previous equal current, so wherever current is pointing, make previous point to the same, right? So we are at this moment current is pointing D, then we are saying make P also point to D, right? And then we are saying current is called next, which means that wherever current is pointing, make C point at the same node. So which means current is pointing to C, so C will also point at this node, right? Then we are saying next is equal next of next position, right? Which means this at this moment this is having null, right? This is having null, so next will have null after this statement, right? This will point to nothing, so this will have null. So we are saying after this statement current of next is this position, this, right? We are saying current of next is called previous. Whatever previous is pointing to, make it point, make this, next position pointer to Sam node, right, which is P, which is this, right? I hope you are getting it, right? So loop, ends and starts again. Next, not null, but next is null. So null not equal null is false, right? So it will come out of loop, and at this moment we have this state, right? So C is pointing this, P is pointing this, right? So we will say head is called current. We are saying that wherever current is pointing, make head point to Sam node. So head equal current. Current is this C, right? So it is pointing this. This node is having address of this node, right? And this node in its next pointer is having null. So we are saying head is called current. So this will point at this. And after all, we will have list like this: head, C, D. We will have C, we will have D, right? D has in its next position null, so this will contain null. And as C is pointing D, C is next is pointing to D, right? And head is pointing to C, right? And at the end of the day, we will have a reverse linked list. So let's implement it and see what we are going to have, right? So I have been working on this, all along, and I will make a new method right here, wired. Let me make sure if audio is working still. Okay, okay, it's working. So I will say reverse, and this will take no arguments, as this is just a command without any arguments. So I have to check if first there should be at least some nodes, right? There should be at least some nodes in our list, right? So I will say if this head, right? Let me show you. We have these properties in our list, which is which are head, which is going to hold the address of the linked list, right? And length, which is going to hold the count of how many nodes we have in our list, right? So what I will say, okay, head. So that means that we should have some elements, right? Whenever there are elements in our list, that means head is going to have some value, right? So whenever head is null, that means we don't have any element in our list. We're going to check the same. What if this head is not equal to null pointer, right? And to reverse, implement reverse, there should be at least two nodes, because if we have only one node in our list, that's or reversing that will be the same, right? So we should have at least two elements in our list, right? Two nodes in our list, right? So we are going to say this length is greater than 1, right? So so if this condition satisfies, that means we have at least two elements and head is not null, right? You can already also check this only this condition, that will make the same sense, but for readability it is better, right? So out of this, what we are going to say, we're going to create 3 pointers, right? Node previous, right, is going to have null pointer, right? The node and current is going to have a null ptr, and node next, right, is going to have what? Head, right? At first this will point, this next will point to the head, starting node in our list, right? So we are going to say while next not equal null ptr, right? So what we say, we slide all the pointers, we advance all the pointers. We say previous is called current, right? Current is called next, next is called next of, next of, next, right? So after this is a pointer, so we have to use this symbol. All right, so at this position we have, you know, all our nodes pointing on something, right? Except previous might, at starting previous might not be pointing to, you know, any node, right? So we will say current of next, right, is equal previous. That's it. Then after all, we have to say head, we have to say this head is equal current. So that will make, you know, the ending node of a list, right? That will make, this statement will make, you know, head point to that, you know, node. So at the end of the day we will have reverse linked list, right? So we are going to call this here. So we have already some elements in our list, right? These are our elements, right? And we are going to display before, you know, reversing the list and after reversing the list display, right? So what I will do, I will run this. C++ simple.cpp output name. I hope there are nothing, right? Okay, so we have, before reverse the list, we had, you know, 10, 56, 2, 22, 4, 5, 22, and after reverse we have reverse linked list, right? 22 is the starting element, 5 second last, right? As you can see, we have successfully, you know, reversed the linked list. I hope you got something from this, and see you later. Thank you.